Good morning. I'm Sharan Santhanam from NEC Labs Europe. I'm one of the maintainers of the Unikraft project, and I'm here to present the Unikraft weather report for this afternoon. And so just as a starter, we just begin with a refresher on what unikernel is. Most of you might be already aware of what a unikernel is. Just to give a refresher or give an intuition behind how Unikraft achieves specialized unikernels is, let's take an example of a web server from a Linux distribution like in Ubuntu. And what we need for that is we primarily need third-party libraries and OS libraries for it. Apart from that, we need some OS components running into it. For instance, the boxes which are on which are highlighted are the primary necessary components to run your web server. So what Unikraft does is just selects those components and builds a customized operating system image and lets you run a specialized customized operating system for your specific application. So how do we go about achieving this? So for us to achieve this one, what we need is we need small libraries to make sure that we can pick and choose the necessary libraries to build the entire custom image as such. So what we did here was we decompose operating system functionalities into smaller libraries. For example, we had schedulers, memory allocators, file systems, and we also had we split it up into three different categories. One is the platform-specific libraries. One is general user libraries, which can be across different platforms, and also different architecture-based libraries as such. And in terms of the interface itself, we provide from an application to the operating system, we provide a Linux compatible system API. So any applications which can run on a Linux user space should be able to run with our application as such. And what we use to build the entire application is using a make-based system, and to configure which of these libraries we need to build for a specific application, we use a kconfig driven menu configuration. So over the past few months, we have been extensively benchmarking our Unikraft project as such with different applications, and we'll be presenting those numbers for you here. The first focus would be on boot times as such. So what we did with boot time was we measured boot times with Hello World applications running on a KVM virtual machine. So what we had was we measured a simple Hello World application with Unikraft, with a Unikraft running in it, initializing Unikraft application, and then just printing out to Hello World with a different configurations. So for each of these configurations, Unikraft puts within tens to hundreds of microseconds. And if you needed to initialize some of the devices, like for example, if you take a net device to be initialized, it takes about 1 millisecond for the guest operating system to be just initialized. And these results were quite similar to other unikernel projects. But the primary time for instantiating this unikernel was within the VMM message. For example, Kimu example takes 64 milliseconds, dominates the time to boot a unikernel. And we also tried it with a new target which has come out, which is the micro VM target, and it comes out to about 18 milliseconds to boot a unikernel. And with our cases, we see that SoloFi and Firecracker, which are these lightweight virtualization mechanisms, perform the best. And the last two graphs which we show is just what happens with a real world application. How long does it take to boot an NGINX application or a SQLite application? Which it takes about 1 milliseconds at worst. And also what we added this year was we added a case for bare metal targets running on a Raspberry Pi on an ARM64 platform. So what we show on the screen, we had a good demo. What we showed on the screen is just to boot off-the-shelf Raspberry Pi operating system and Unikraft running bare metal on a Raspberry Pi platform. With that, what we get is in terms of comparisons, we get a boot time of 5 milliseconds to just boot our Unikraft with on a Raspberry Pi platform. In comparison to Linux, though it's a bit of an apple to orange comparison, what we wanted to just demonstrate here was our level of modularity in terms of how well we can strip down our kernel and make sure that we can boot up a separate application as such. Yeah. And yeah, this just gives us an information on how much is the boot times for bare metal application where we run in a Raspberry specialized application and different applications to run on a bare metal target like SQLite. Everything on Unikraft is since optimized. We get around 80 milliseconds, whereas with Unikraft to boot it and on Linux environment, it's about 3 seconds to get it up and running. Yeah. So the next target we had was the memory footprint as such. So our idea was to evaluate how much would be the image sizes and what would be the memory footprint to run multiple images Unikraft applications on the target VM. So with that, what we ran was we first ran into we computed image sizes for 4 standard applications. One was a Hello World, NGINX, Redis, and SQLite. And with that, Unikraft size varies from a few hundred kilobytes to 1.1 megabytes to boot it on a KVM platform as such. Whereas if we compare it with other unikernel projects or with a Linux user space application, which is with a statically compiled libc libraries, we get around a few megabytes in size of, that's the image size as such. And the next target was to understand the memory consumption from Unikraft perspective versus the different targets. Like what we did was for Unikraft, the same 4 applications, we compared our memory usage, and it varied from a minimum of 2 megabytes to a maximum of 6 megabytes to just get the application running on the Unikraft target. Whereas if you take that and compare it with, say, a Docker image, or with other unikernels like Hermitex or Rumprun or OSV, or even Alpine Linux, we are at least a magnitude or order of magnitude fast or less consuming memory in terms of, yeah. And the next target we had in our mind was network performance, and for that what we did here was first we wanted to measure the throughput performance of just a bare metal the native UK native API, which is the API on which the networking stack is built upon. So with that, what we did was we tried to bring in DPDK libraries on top of it and compare it with a DPDK library running within a Linux VM and Unikraft native library with running on top of UK native. And in terms of performance, we are able to match a DPDK library running within a Linux VM and with Unikraft. What we tried to do with this measurement was we tried to send out packets either using vhost user, which is a DPDK offloading library, or with a vhost net, which is a network, the kernel-based acceleration, and receive the packets on a 10G network interface and measure it on the receiving end, on how many packets we are receiving at that point in time. And and then what we did was we wanted to compare the different applications and see what is Unikraft's performance in terms of a network application perspective. So what we did was we took an off-the-shelf NGINX application and had LWIP as a network stack within Unikraft, and then that runs on top of our UK NetDev APIs. So what we get out of this comparison is we didn't modify anything on the NGNX part. We didn't optimize it, but our optimizations were basically on LWIP layer, where we tried to use memory pooling to get maximum performance. And with that, what we are able to show here is we are able to match Unikraft bare metal application running with that of a Linux in terms of the number of requests per second. And if you're comparing with Docker or a Linux KVM application running NGNX, we are at least 10 times faster, or at least twice as faster as compared to a Linux VM. And if you had to compare it with other unikernel projects like OSV or Rumturn, we are 2 times faster in terms of output itself. Similarly, we did the same test for Redis to measure our output. And in terms of with Redis, if you get to compare it with the bare metal Linux implementation, we are actually much faster in terms of bare metal performance, and we are able to match. We are also much faster than other unikernel projects and Docker environment. So I think in terms of performance, we are outbeating these other projects. And the next part is the application porting itself. What does it take to port an application? So in terms of the range of porting itself, you have multiple ranges, right from a manual porting of an application to a fully binary compatible mode. So Unikraft currently supports statically linking of binary. Once you have statically linking of binary, and if you load it into the image, you are able to run a statically externally built application with Unikraft. So to enable that one, what we needed to do was we had to build something called a syscall shim layer. And what it does is, whenever the statically linked library makes a syscall interface, what we do is we map it directly to the Unikraft functionality. All of this is done at compile time. But and what it does is, when a syscall is being invoked, what it does is it just restores state of the registers, calls the corresponding handler, comes back, returns the value, and this is completely transparent to the application running on top of it. And to measure that, we were doing some performance measures. What we did here was we wanted to try to run Unikraft with SQLite and compare it with running Linux with SQLite benchmark. What the benchmarks does was we tried to run 60K inserts and see how well we are performing. And in terms of performance, we were able to better the performance of Linux. And if you were to compare the last two graphs, which is the manual porting versus the binary compatible porting, we are able to perform much better with the manual porting, but because of the interactions involved with the binary compatible mode. And this one, we were able to achieve about 1.3 seconds to complete this benchmark. But the underlying RAMFS layer, where we were inserting the queries, wasn't completely optimized. If we were to optimize it further, I think we would be able to perform much better. In terms of the tools and the ecosystem message, so what we added with Unikraft with this latest release is a new tool called Craft. The idea behind Craft is we wanted to enhance the experience of building unikernels. So what it does is it lets you it enables a application developer or a user just to track all the library dependencies, configure your builds, run your builds. So what you just need is, there's some basic commands to run it. You just need to initialize your application. It just builds it and you can run it transparently. So everything is being orchestrated by this craft tool, which was introduced with our latest release. And where can you find us, right? We all our repos, all our code is open source, and all of it is hosted in Zenbits. We also have a read-only copy at GitHub. And apart from that, there are some additional libraries which are not part of the core repositories, which are part of GitHub alone, just to help us build a developer ecosystem there. And you can find more information about our projects at the website unikraft.org. This is some more information on other sources and contributions. If you're interested, please get in touch with us. And yeah, the next part is the final, what is the latest release and what is the status of the history of the project itself. So in terms of the latest release, we made a release called RIA on February. The primary highlights were we had an external platform supporting Solo 5. We were supporting different language runtimes like C++, Python, MicroPython, Go, WebAssembly. And also we made some improvements on the ARM64 port itself, adding threading and TLS support on top of that one. And then we have additional file systems to support 9pfs. On KVM platform, we had RAMFS and DevFS on top of it. Apart from that, we also introduced this craft tool for help to enhance the experience of a developer. In terms of the contributions, it's primarily an open source project with primary contributions from Polytechnica Bucharest, NEC, ARM is one of our contributors, and there are other universities like Lancaster and Liège who are contributing to a project. And in terms of community growth itself has been quite good, and we always welcome new people to contribute to us. If you're interested, please write to us through either the mailing list or through one of these channels. Thank you. If you have any questions, I can take it up now. Yeah, currently we do not, for ARM64 platform, we primarily run on KVM. We are expected, the work for supporting it on Xen platform would come later. And if someone from the community is also interested, we would welcome you, and we could help you, help us with the port of the ARM64 platform. That's a good question, because we are not yet deploying it in a real world production environment. So we do not we just want to support a maximum number of platforms. If we have different use cases, we would support the different platforms as such. We've been having discussions with some of the industry partners. They are trying to push us into certain paths. So it is still in talks on where we could use it, how we can prototype it, on where are all the use cases where they find it interesting. So we are still exploring that path as such. Yeah, you see, that would be an interesting proposition for us. I mean, say we tried different KVM platforms because we had a more stable KVM base, and we tried it with different VMMs on Firecracker. So because function as a service was an interesting use case for us to boot up unikernels whenever we need. So that was one of the reasons why we were trying to explore KVM and different virtualization technologies based on that one. But if it helps us with a faster boot time, I think it would help us also. Support for booting only for first. I don't think we tried it yet for the paravirtualized mode. No. Is it with the PVH? Are we talking about? Yeah, are we talking about this? BIOS? Yeah.
So basically, they're using PVH for being able to test kernels much faster without having to boot BIOS or things like that. And so they, instead of the BIOS, they're directly using the PVH boot method and directly booting the kernel this way. And I think this could be used for Unikraft as well. So especially on x86, of course. So that's x86 specific. Might be perfect for you.
Yeah, I think one of the persons, if micro VM does that, we already tried it on micro VM boot as such, but I'm not completely sure on the internals of it yet.